Have you ever grappled with that underlying frustration, that feeling that things just aren't as smooth or consistent as they could be?
Yeah, definitely.
Maybe it's a big project at work, hitting snags, or, even something simple like getting everyone to load the dishwasher the same way at home.
Ah, yes, the dishwasher standard.
Right. It often feels like there must be a clearer path, doesn't it?
Hmm.
Well, what if I told you there's a powerful, historically proven concept that offers maybe a shortcut to clarity and excellence?
Okay, I'm listening.
Today, we're taking a deep dive into exactly that, standard work. And our guide for this is a foundational source, OpEx, Standard Work, by Vishnu Rayapeddi.
A great resource.
Our mission here is to really unpack what standard work is, look at its surprising origins, and understand how it can streamline processes, prevent errors, and even transform leadership, all to help you achieve operational excellence.
And it's interesting because while standard work sounds maybe a bit basic, almost like just writing things down.
Right, like a simple checklist.
Exactly. But its depth and how widely it can be applied, that's what's truly fascinating. It pops up in places you wouldn't expect.
Okay, so let's start right at the core. When we say standard, what are we actually talking about here?
A standard, fundamentally, is a clear rule or an agreed-upon example. It sets expectations.
So it's the baseline.
Precisely. It's the baseline for any improvement activities.
Yeah.
And, crucially, it helps define those breakthrough goals you're aiming for. It's the foundation.
Got it. So building on that, how does standard work fit in? The source defines it as.
An agreed-upon set of work procedures that establishes the best and most reliable methods and sequences for each process and each worker.
And those keywords seem critical. Agreed upon.
Yes, buy-in is essential.
And best and most reliable. Not just any way, but the optimal way identified right now.
Exactly. The current best practice.
Okay, conceptually that makes sense. But where did this idea actually come from? It feels like it has some history.
Oh, absolutely. It wasn't just thought up recently. Its roots are deep in the Toyota production system.
Toyota, Daiichi Ono, right?
That's the one. Post-war Japan. Ono was famous for just observing, standing on the factory floor watching.
And what did he see?
The critical thing he noticed was variation. Even for the exact same job, different operators were doing it differently.
No consistency.
Zero consistency, which meant zero predictability in the output.
So that observation was key. What was the next step? How did he go from seeing the problem to, standardizing it?
That was the genius move, the aha moment. He didn't just point fingers. He watched the most efficient workers, learned from them, and then documented the correct sequence of operations.
So he wrote it down.
Wrote it down, standardized parameters like how far to walk, how to hold a tool, the precise steps, and he eliminated waste like unnecessary walking or searching for parts.
And the immediate result of doing that?
It was quite transformative. Suddenly, they could predict output with much higher accuracy.
Because everyone was doing it the same way.
Exactly. That consistency directly led to a really significant boost in productivity. It proved that predictability and efficiency come from consistency.
Okay, so understanding that origin, what are the main purposes? Why would an organization or even, an individual bother implementing standard work?
Well, the core goals are usually improving safety, achieving high quality, lowering costs, and boosting efficiency. Pretty fundamental stuff.
I speak the big ones, yeah.
But it also creates this shared understanding, a common language for how work gets done. It shifts the focus from individual quirks to improving the system itself.
That makes sense. And what about the benefits? You mentioned operators and the company.
Right. For the operator, the person doing the work, it actually makes things easier. It's easier to learn new tasks.
Because there's a clear guide.
Exactly.
Yeah.
It's easier to switch between different jobs, making them more versatile. And importantly, because the standard is clear.
They can see when something's wrong.
Precisely. They can spot problems more easily and suggest improvements. It empowers them.
And for the company.
Big benefits.
Yeah.
Less variability means fewer errors, less rework, so less waste and lower costs.
Quality goes up.
Quality improves consistently. And you get shorter, much more predictable lead times. Customers are happier.
Okay, so connecting this back to, the listener, how does this simple-sounding concept actually create such concrete results in practice?
Well, first, where do these standards even come from? It varies. Sometimes it's custom or consensus within a team.
Just agreeing on the best way they know?
Right. Or it could be based on hard scientific data or just long-term experience. Sometimes technical specs dictate it.
Like an engineering drawing.
Exactly. But once established, that becomes the agreed-upon method.
And then it's all about adherence to reliable methods, making sure people actually follow the standard.
Yes, and that means communicating it simply, clearly, no ambiguity. Everyone needs to know it.
And be able to follow it easily.
Correct. Make the right way the easiest way. Don't put obstacles in their path.
And it's not static, right? You mentioned improvement.
Absolutely not static.
Yeah.
It's a cycle. Identify problems in the current standard.
Find the root cause.
Yes, dig deep. Don't just patch the symptom, then integrate the solution back into the standard.
So it constantly evolves.
It has to. Continuous improvement.
Now, a key concept you hear about, especially in manufacturing, is work balancing and TAKT time. What's that about?
Takt time's a German word, means beat or rhythm.
Okay.
It's basically the rate you need to produce to meet customer demand. Like, we need to finish 1 unit every 5 minutes.
So it sets the pace for the whole operation.
Exactly, the pulse.
Yeah.
And work balancing is about making sure the workload is distributed evenly across the steps or stations.
To avoid bottlenecks.
Precisely. You identify the bottleneck, the slowest part, and improve it. Or you share the load by reallocating tasks.
The source had visuals of this, unbalanced versus balanced lines.
Right. The goal is a balanced line where work flows smoothly, nobody's idle, nobody's overloaded, much more efficient.
This ties into standard work sequencing, doesn't it? The order of operations.
Yes, nailing down the most effective sequence of tasks. And you need to ask questions like,
How many people do we have? Is anyone waiting around? Is one person totally swamped? How much inventory builds up between steps?
asking those questions reveals the imbalances and opportunities for better sequencing.
Are there specific tools people use to create these standards?
Yes, the source mentions several. There's a parts production capacity work table.
To see what equipment can do.
Right, a standard operations combination chart to see how people and machines interact over time. A work methods chart for really detailed hand movement.
Okay, very granular.
And the standard operations chart, often called the standard worksheet, that's usually the summary, ideally on one page, showing the sequence, key points, time, inventory.
The main document people use day to day.
Generally, yes, it brings it all together.
And all this feeds into the constant improvement of operations, right? Looking at material flow.
Improving material flow, moving towards multi-skilled workers who can do more tasks.
Making motions more efficient, setting clear rules.
Improving equipment, sometimes separating people and machines for safety or flow, and a big one, preventing defects, building quality in.
Now, a common problem must be the documentation itself. Manuals can be pretty awful sometimes.
Oh, definitely. A huge challenge. Often they're not designed for the actual user. They're written by engineers for engineers, maybe.
Revisions are messy.
Totally unsystematic. Changes happen on the floor, but the manual doesn't get updated for months, if ever. And the info might not even align with lean thinking.
So how do you make them user-friendly?
Brevity helps. Ideally, one page for specific tasks standard. Clear objectives, control points, key data.
Use symbols, pictures.
Absolutely. Symbols, simple data charts you can use during the work, photos, drawings, anything to make complex information easy to grasp quickly.
Makes sense.
And organizing the material in the actual work sequence is critical. Don't make people jump around.
Prioritize the important stuff.
Yes. Highlight critical steps or safety points. Use terminology the operators actually use, not confusing jargon.
And keeping them updated requires a proper revision schedule.
Essential. You need a system to regularly review standards, capture all the process changes, and then this is crucial, retrain people on the changes.
Otherwise, the standard becomes obsolete.
Exactly. And you need to ensure the information reflects new methods or techniques. If problems occur, the standard should describe the corrective action.
What to do if something goes wrong.
Right. And clear directions if the standard isn't followed. How to get back on track.
Okay, let's shift to some really powerful applications. Mistake proofing, or poka-yoke. This sounds fascinating.
It really is.
The source uses that example of trucks hitting bridges despite warning signs. Why isn't a sign enough?
Because humans make mistakes. We get distracted, we're tired, we misjudge. A warning relies on the human noticing and reacting correctly every single time.
Which doesn't always happen.
Exactly. Mistake proofing, or poka-yoke, aims to prevent the mistake from happening in the first place, or detect it immediately. It engineers the error out.
Through things like self-checks.
Self-checks, source inspection checking inputs before they cause a problem, and designing processes so the mistake physically can't occur or its influence is stopped.
I feel like we see this in daily life.
All the time.
Yeah.
Think about gas pumps, those breakaway couplings that shut off fuel if you drive off.
Oh, right. That prevents a disaster.
That's mistake proofing. Or a USB plug only fitting one way. Simple, but effective.
Prevents you from damaging the port.
Exactly. There are different systems too. Control systems actually stop the machine or process if an error occurs.
Like an emergency stop.
Sort of, but automatic based on sensing an error. Warning systems just alert the operator, a light, a buzzer.
So they need to react.
Yes.
Mm.
And one way only. Processes are physical designs where assembly, for instance, can only happen the correct way.
Making the wrong way impossible.
Pretty much.
Another huge application area mentioned is standard training and TWI, training within industry.
TWI.
Yeah.
Its historical impact is massive, truly massive. This was the training method used by Toyota and Nissan in the 1950s. It was fundamental to how they trained their workforce rapidly and built their culture of continuous improvement.
Wow, so it goes way back and was foundational for them.
Absolutely. A cornerstone of their success, genuinely.
What are the components of TWI? There were 3 modules.
That's right. First is Job Instruction Training, JI. That teaches supervisors how to train their staff to do a job correctly, safely, conscientiously. The how-to of training.
Okay.
Then Job Methods Training, JM, which teaches supervisors how to analyze and improve the way jobs are done for efficiency, quality, better resource use.
Improving the standard itself.
Exactly. And third is Job Relations Training, JR. This focuses on leadership skills, how to handle people problems, prevent conflicts, build positive relationships.
So how to train, how to improve methods, and how to lead.
A powerful combination. And the core principle underlying all of TWI is learn by doing.
Not just classroom theory.
Definitely not. Training has to involve hands-on practice with a real job or a real problem from their work. It's about application, not just listening.
And part of GI involves the job breakdown method.
Yes, a really practical tool. You break a task into its main important steps.
The core actions.
Right. And then for each step, you identify the key points.
What are those?
Key points are anything that might make or break the job, injure the worker, or make the work easier, tricks of the trade, safety precautions, quality specs, the critical details.
The source had that PCB insertion example.
Yeah, like step. Pick up housing in PCB. Key point.
Okay.
Hold PCB by edges prevents contamination. It captures that crucial know-how.
And the JI training itself follows a 4-step process.
A very structured, effective process. Step 1, prepare the learner, put them at ease, state the job, find out what they know, get them interested, position them correctly.
Set the stage for learning.
Exactly. Step 2, present the operation. Tell, show, and illustrate one important step at a time. Stress the key points. Be clear, complete, patient. No more than they can master.
See it, hear it, understand it.
Right. Step 3, try out performance. Now they do the job. Correct errors immediately. Have them do it again, explaining the steps and key points back to you.
Ensuring they really understand why.
Yes, deep understanding. Keep going until you know they know. And finally, step 4, follow up. Let them work on their own, but designate someone for help. Check back often at first, encourage questions, then taper off.
Build their confidence and independence.
That's the goal. It's a proven method. Taiichi Ohno himself credited TWI's one best way idea as the bedrock of Toyota's continuous improvement.
That's quite an endorsement. It's amazing how powerful these seemingly simple structures can be.
Absolutely.
So if standard work is so effective for operators, for training, does it stop there? What about leadership? Can you apply this to managers?
You absolutely can, and according to lean thinkers, you should. It leads to standard leader work.
Okay, tell me more.
The principles are the same. Applying standard work to what leaders do makes the management system itself process-dependent, not person-dependent.
Meaning it works consistently regardless of who is in the leadership role.
Exactly. So many businesses rely on the specific skills or habits of individual managers. If that manager leaves, things can fall apart. Leader standard work builds resilience.
It makes the system strong.
Right. The source calls it the first principal element of lean management.
So what does leader standard work actually define?
It's designed to show leaders clearly what to do and what not to do.
Bringing that same clarity and agreed upon best practice to their routines?
Yes. How they check on processes, how they engage with their teams, how they follow up on issues, making their positive impact predictable and repeatable.
And it supports the operator standard.
Oh, definitely. It's layered on top, as the source says. Production, the core work, is most important. Leader standard work includes things like checking visual controls, running daily accountability meetings, ensuring the standards are being followed and improved. It's how leaders actively support and reinforce the whole system.
Wow. Okay, when you lay it all out like that, the scope of standard work is, well, it's huge.
It really is.
From efficiency on a line to how we train people, preventing mistakes, even how managers manage. It touches so much.
It does. It boils down to clarity, consistency, and that engine of continuous improvement. And like we said, it applies far beyond just the factory floor. It's about designing reliable systems.
So, thinking about all this, here's a final thought for you, the listener, to chew on. If standard work can reshape complex manufacturing, if it can guide leadership, how might standardizing just a small, simple part of your daily routine? Maybe even just how you make your morning toast.
The toast standard.
Right. Or maybe how you prepare for an important weekly meeting. How might applying that thinking reveal inefficiencies or even new ways to achieve a little bit more excellence you hadn't considered?
It's a powerful lens to look through.
Definitely something to reflect on. Maybe pick one area this week. Where could a little standard work make a surprising difference for you?